Greetings. So in this video, we're going to take a look at the Sagnac experiment and how it defies relativity and, in my opinion, how it shows that the ether exists. And so first we're going to take a look. There's a video that I found that Mr. Bowden, Malcolm Bowden, does where he explains the experiment. So I'll show a clip of that. And then I'll show how they measure the difference in the light travels in the light waves, using light waves, okay? And so we're going to take a look at this and how it's used in aircraft to show any pitch or yaw. And so we're going to dive into this and let's take a look.
A beam of light leaves the light source at the bottom left-hand corner and is split into two different beams, which we have coloured red and blue just to distinguish them. They travel round the circuit in opposite directions until they eventually reach the splitter, which also recombines them. There, they then go on to the photographic plate, where they have interference fringes. In this simplified version, we see that the beam is split into two, the red and the blue again, and they go round the circuit and are recombined at the splitter and recombining prism so that they again produce the fringes on the photographic plate. Now let us rotate the table. Before we do so, there is the very important subject of the effect of the ether. The Michelson-Morley experiment failed to detect the 30 kilometers per second motion of the Earth through the ether. So to overcome this problem, Einstein simply abolished the ether in his relativity theory. The very significant result of the Sagnac experiment was that it proved that the ether existed. Let us see how it did this. It is a fundamental feature of relativity that it claims that as there is no ether, light travels away from a source at the same speed relative to the source, whether the source is moving or not. Thus, whether the table is turning or not, the fringe patterns should stay the same. But if the ether exists, once the light has left the source, the speed of the light is controlled by the ether, independent of the speed of the table, mirrors, etc., as we see here. So let us see what happens when we rotate the table. Here, the light is split, and the red and blue lights go in opposite directions. But notice that the left-hand mirror has moved around in such a direction that the distance the red light has to travel is further. Now in relativity, the same time should be taken because the splitter is also moving and the distance between them is the same. But now imagine that the ether exists and the speed of the light is controlled by the stationary ether. Imagine the ether like a thick treacle that limits how fast the light can travel, independent of the motion of the light source, the splitter, or the mirrors. The result is that the red light takes longer to reach the left-hand mirror. Similarly, the right-hand mirror is coming towards the blue light, so it reaches the mirror quicker. After they change ends, the red light again takes longer to reach the recombiner, whilst the blue light gets there quicker again. So they reach the photographic plate with a delay between them, and this changes the fringe pattern. In fact, Sagnac, using the speed of the rotation of the table, calculated how much the fringes should change, and found that they did change by just that amount. The crucial feature of this experiment is that it demonstrates that the ether does exist, which demolishes relativity.
So in relativity, you always hear the question about if a man's on a train and he gets in the back of the train and he gets up and walks towards the front of the train at 1 mile an hour, but the train is moving 5 miles an hour, how fast is the man moving? And you say, well, relative to the train, he's moving 1 mile an hour. If you're on the train, that's how you perceive him. But relative to the ground beneath him, he's moving 6 miles an hour. 5 miles an hour for the train plus the 1 mile an hour that he's moving. But light doesn't work that way. It's always observed at the same speed. And that's the whole point that I'm trying to make to this video, is that it's traveling through the medium, which is ether, which is electrical pressure. And the light is traveling through the ether at the controlled speed by the ether that it can go through based on the electrical pressure or the ether. So that's why light is different. It's always observed at the same speed, regardless of how fast you're moving. And that's where this experiment, people are throwing a flag on the field and saying, wait a minute, this Sagnac experiment proves the ether. It can't just be straight up relativity, or this experiment would not work. So also it also shows where there's no rotation of the Earth or any of the other motions that we're supposed to be experiencing, because the light would never come back the same. When the table's not moving, it should, because of the rotation of the Earth and the rotation of our galaxy and all that, the light should never come back the same. There should always be it should always detect movement, but it does not. So this Sagnac effect is also used by aircraft to determine if the aircraft is rotating. So it helps determine pitch and yaw. And so one might be thinking, well, how can it detect such a minuscule amount? And that's because light travels in waves. And I did a whole video on photons aren't what we think, that they're not a physical thing. They're just a point in a wave. And so anyway, I digress. But if you look at this image here, you can see the red and the blue is what I want you to pay attention to. So you can see that the patterns are offset. And so that's what this computer equipment is looking for, is the offset pattern. And it's using this offset pattern to measure how much pitch it has, for example, the aircraft would have. So that's what it's looking at, just as a side note. It doesn't measure photons, although I hate to use that as an example because photons aren't a real thing. It has modality, has modal properties, but no physical attributes, in my opinion, and I did a whole video on that. But that's what, just for your own knowledge, that's what the computer is measuring, the frequency difference between in this example, the red and the blue. They're just labeled red and blue so you can see the difference, not to be confused with like a redshift. There's none of that. It's just the difference there. So you can see that the red and the blue is not hitting, in this case, the photographic cell, not hitting that at the same time. The frequencies are different. So that's how it's measuring movement. But according to relativity, they should always hit the same. They only hit the same when things are stationary, which shows that the Earth is stationary. Because if the Earth was spinning, then this experiment would never work. These frequencies would never line up, but they always line up unless what the experiment is on is moving. So in conclusion, the Sagnac experiment, the Sagnac effect, as it's called, is very fascinating, and it defies relativity, shows that there must be some kind of electrical pressure that the light travels through, and this is why it's always observed at the same speed. Thanks for watching, and as always, have a great day.